Hey guys, hey, today we're going to go ahead and cover 1.3. I hope 1.2 was working okay for you. I did go back and check through Dodge City and I don't have any submitted, but that doesn't necessarily mean you're not working on it. Also wanted to remind you I would like that individual plan, or the individual information sheet that filled out. I know Tyson's got it turned in, but I'm still waiting on a couple others. Hey, today we're going to talk about problem solving, a big concept that we need to cover in all math classes. Today we're going to use what they call the four-step steps in problem solving. And you may have seen variations of this throughout your education. But the one that they use, usually there's always going to be one to read the problem and understand it, devise some kind of a plan, carry out that plan, and then of course probably the one that I honestly, personally, probably tend to forget a lot of times is to look back and check that answer. And so, but we're going to go ahead and cover some of the different ways that you are, kind of the types of problems you're going to have. I want you to also think in terms of a lot of times when we do problem solving, we're saying, well, just get the answer. Solve it algebraically and just get it done. But there's so many different ways that you could do that. You could, look for patterns or look at the chart. If you'd be here today and we weren't online, we would spend just some series and sequences to kind of give you guys an idea of how you can also solve just by doing some trial and error. There's also charts and graphs. You could also make a list. There's a jillion ways you can also problem solve. But we kind of tend to show one and then on. But today we're going to go ahead and some of the problems that you're going to be seeing will look like this. Like a man purchased 5 shirts and each at the same discounted price. How much did he pay for them? Well, now, if you look at this problem and you're saying, okay, I'm supposed to find out how much he paid for them, all I know is that I've got 5 shirts. And so I'm going to struggle coming up with a plan to find out how much he's going to pay for them because I'm not giving it. So today you're going to be asked to look for something that's missing. And then obviously this one is going to be missing the cost. Okay, the cost of the discounted price. Or the cost of the shirt. You're going to need to have something that is missing in that problem that it makes it so you cannot solve it. Now the second one, you might have some extra information too. So it says a salesman received a weekly salary of $350. In addition, $15 is paid for every item sold in excess of 200 items. How much extra was received from the sale of the 212 items? Well, so if I'm solving this, if I'm going to look for how much extra is just received that I'm going to get, really I'm going to just need to know that I sold 212 items, but for every item over 200, I'm going to get an additional $15. So I've got to find out what that is. So that's going to be then minus the 200. That gives me 12 items over. And so I'm going to get another $15 for every one of those items. And so that's, again, a multiplication problem. So I'm going to multiply it times 15. So really, the idea from this problem that they gave us, we didn't even need this information at all. And so the fact that he did get a weekly salary of $350 really is irrelevant, is not necessary. So the other types of problems, so if we, let's see, make sure I get it. By paying $100 up front and a balance of $20 a week, how long will it pay for a bicycle costing $680? So again, when we start to think about how much, again, some of the things that I will do is I'll go ahead and underline the parts here. So for instance, how long, we know that we're looking for the amount of time it's going to take for us to make up that balance. So again, what we need to find out though and understand, we're going to have to take our total cost, which is $680. We're already, before we walk out of the store, we're going to actually pay $100. And so I'm going to need to find out how much am I going to owe. And so that's going to end up being $580 that I owe. But then for every week, I'm going to pay $20. So again, that means that I'm going to have to divide. I could keep in mind, I might go minus 20 and keep going that and just add up those. That would be a solution. But knowing that I'm going to have to do that multiple times, I think it'd be a better way for us to just go ahead and jump into division, because I'm going to find out how many times 20 goes into 580. So by doing that, I'm going to I'm going to go 580 divided by 20. Let me just grab my calculator. 580 divided by 20 is 29. And so if I had done this activity, I had to gone 29 times before I'd have gotten to the answer and gotten to 0. And again, that would take a way more time than I really wanted. I also notice I just grabbed my calculator, and we tend to always. I have a feeling you guys were not. I am not the only one with the problem in this, but keep in mind when you have a problem like this, sometimes even just writing it as a fraction and then just simplifying. I mean, I can in my head go 558 divided by 2, and just by doing that, I'm still going to get that same answer. But keep in mind, we need to be careful that we still don't just automatically just grab our calculators and use that. Now again, so that's my plan. Okay, and then we're also going to go ahead, we carried out that plan, and we're going to check. So if we're going to check, that means I'm going to take the $29 and oh no, it's not $29, it's 29 weeks. Sorry about that. So I'm glad I checked. So I'm going to change that. I'm going to go weeks. But I'm going to multiply it times the $20 now. I've got the dollars. And then I better be able to add 100 and get that same answer, and it should equal then the 680. So by reversing that process, 29 times 20, maybe if I could go 29 times 20, not plus 20, that would help. And then if I add 100, I do go ahead and get that $680. And so that's, again, a good way to go ahead and check to make sure that I've done the problem correctly. The next question I have, it says, which is a better value for a 15 3-ounce box of cereal that costs $3.37, 24-ounce cereal that costs and cents. And it says the supermarket displays the unit price for the 15.3-ounce box in terms of the cost per ounce, but it displays the unit price for the 24-ounce box in cost per pound. So notice that when you have a difference in those, that changes your results. What are the unit prices to the nearest cent given by your supermarket? And so when we look at this, the devising a plan, okay, so we're first going to say that box 1 is going to be then 15.3 ounces, and it's going to cost us, I'm just going to put an arrow, $3.37. Box 2 is going to be then 24 ounces, and it's going to cost us $4.59. And so we're going to want our plan and understanding the problem. We need to determine which one is going to be better. And so by starting off, we want to go ahead and decide how much is going to be per unit. And again, you can actually do, we could do it cost per pound, but I wouldn't, because both of our items are in ounces. And so to solve this, we're going to find out how much it's going to cost. So box 1, we're going to have then, let's go ahead and just, we're going to take then the cost, which is going to be the $3.37, and we're going to divide it by the 15.3 ounces. And so that will tell me my cost per pound, or per ounce. Okay, so by doing that, I'm going to go 3.37 divided by 15.3, and I get then that it's going to cost me about 22 cents per ounce. And if I do box 2, I'm going to do the same thing. But this time I'm going to go ahead and say that I have then $4.59 over then the 24 ounces. And so when I 4.59 divided by 24, our cost per pound or ounce would be then 19 cents per ounce. And so when we look at what's a better buy, box 2 will be the better buy. And again, some of your problems you might find by how much. And so again, by the difference between those two would just be the subtraction of that. And so based on your work from parts A and B, does the better value always have the lower displayed unit price? And so in this case, no, they wouldn't, because the fact that when you do the different, you have to check to see that you're using the same units. Problem number 5. So one person earns $48,000 per year, and another person earns $3,750 per month. How much more does the person earn in a year than the second? And so again, what our plan is going to be, we know how much, since we are comparing it by year, and they gave us the person number 1, we already have the amount that but the second one we don't have the amount that they make per year. So that's what we're going to have to find. So first of all, we want to go ahead and say that we have the 3,750. So person 2 is 3,750, and he gets that amount per month. But we would have then 12 months. And so what we want to do is we want to find out how much is he going to make per year. So 3,750 times the 12 gives me then the 45,000. And so in this case, when we're comparing, this is going to be person 2. And we know that person 1 is going to be 48,000 a year. Oops, that's an 8, not an. Then I know that the person number 1 is going to make a little bit more. And then they also said how much more does he make. So in other words, they're looking for the difference between the two. So by taking 48,000, subtracting it from 45,000, then you're going to end up, then he makes then $3,000 difference. Okay. Does it look like it makes sense? Again, you wanted to go ahead and double check your work here, and just by multiplying it back on through. The next problem that we have, it says calculators are purchased for $65 per dozen and sold for $20 for 3 calculators. The profit for 6 dozen calculators. Okay, so again, when you do this, I'd still hard on your homework, like on your problems on the computer, but make sure you take note of the fact that when we have 6 dozen, so we're talking about then 72 calculators and not just 6. So read the problem carefully. So calculators are purchased for $65 per dozen, and then they were sold for $20 for 3 calculators. So if you think about what our goal is for finding it, we're going to have to determine the profit of the goods that are sold. So we're going to start off by taking we can find out from that 6 dozen calculators. We can go ahead and we know that for every group of calculators that we have, if we sold 6 dozen, and then, so if we have $65 per dozen, and that would be for the 12 calculators, what I would do is I would find out how much I would spend on each of the calculators. So my cost would be then 65 then divided by the 12 dozen, so $65 per dozen. And then that would tell me what I would have for each calculator. 65 divided by 12 gives me $5.42. But then I'm going to sell, I'm selling $20 for 3 calculators and find the profit. So on 3 calculators, so if I multiply $5.42 times the 3 calculators, that would cost that I have for my calculators. Times 3. So that means my cost is going to be $6.25. Now I'm going to sell them for $20 each. So my profit would have to be the $20 minus then the $16.25. Now, on this one, I'd also like to talk to you about the ideas. It's nice when you have a calculator that has a button that you can arrow up and select a number that you've already used. If you don't, it's not a problem, but it does help in some of the problems that we have down the road. So, in this case, so we know that for every time we sell 3 calculators, we're going to make then $3.75. So now I'm going to have to I need to figure out how many, if I have 6 dozen calculators, how many groups of 3 would I have? And so I have then the 6 dozen would be 6 times the 12, or 72 calculators, but I'm grouping them into 3, and then I'm going to have a profit of $3.75. So that means I need to take the 72 divided by 3. That tells me I'm going to have 24 groups of 3 calculators. And then I would have then for every group I will make $3.75. So I'm going to multiply that times then the 24. And so I should have a profit then of about $576 for my profit. Now, I'm going to tell you there's a lot of different ways that you could actually accomplish the same problem by going a different route. And so remember, just because you didn't do it exactly the way I did it does not mean that you won't get the same answer. The next problem we have is sometimes it helps to make a list. Okay, so you're an engineer programming an automatic gate for 50 cents a toll. And the gate accepts change only but does not accept pennies. How many coin combinations must you program to the gate to accept? So if you think about it, this is one when we set up a plan. We know that we have a total of 50 cents. And so if you think about all of the coins that we could have a $50. We also could have quarters. We could have dimes. And we could have nickels. And again, it says that we don't have the pennies. And so when you set up your chart, a way to solve this one would be just going ahead and filling it out. Remember, all of these columns that we have, we're going to have to equal then the 50-cent toll that we have here, so 50 cents. So in other words, I could have one $50, but then I'd have 0 of the other. Okay, after that, I'm going to have 0 $50 because I know that I can't go any further. So then I'm going to start off with the most number of quarters that I have. So if I have 2 quarters, that equals 50 cents, and so that would make it even, so I'm going to stop. I could also have just 1 quarter. Then I'm going to start off with the highest number of dimes that I have, which would be 2. And so again, I have 25, and then this would give me then another one. That means I'm going to be missing 5 cents by adding those up. So then remember, I could keep going. I'm going to go 1 quarter here, and then I could also have just 1 dime, but then that's going to, I need to add then 3 different nickels. Okay, I could continue going on with 0, I could go with 0 dimes, because in each one of these I'm going to go down until I get to 0. So in other words, I'm going to go 1 here, I'm going to go 0, but then this time I could have 5 nickels. So the next one, I'm going to, now that I've exhausted all of my dimes, I'm going to say that I'm going to have 0 quarters, and I could have, the most number of dimes would be 5. And then I'm just going to keep going down with the 5. So it's going to be 4. So if I have 4 dimes, that means I'm going to have then 2 nickels. If I go 3 dimes, I'm going to have then 2 more nickels, or 4. If I go 2 dimes, then I'm going to end up with then 6 nickels. And if I go down to 1 dime, then I'm going to have then 8 nickels, and then of course now I'm down to 1, so it's 0, 0, 0. I could have 10 nickels. Okay, so that's kind of the problem that we have, and so it says how many different coin combinations must you program? Well, the number would be then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different coin combinations. Okay. The next example, using a diagram. For 4 runners are in a 1-mile race, and you have them listed here. Points are awarded by only to the women finishing first or second. The first place winner gets more points than the second place winner. How many different arrangements of the first and second place winners would be possible? So if we start off with our very first person, and let's say that Mara, I think Mara happens to be the first place. Then our second place person could be any one of those 3. So, and I'm just going to go ahead and put the initials A, T, and D. Okay, and so the possible combinations would be then Mara getting first, Arthena getting second, Mara getting first, and then Thelma getting second, and Mara getting first, and then Debbie getting second. But then we need to go ahead and do the rest of them. So in other words, if I switch them, I'm still going to have then the Arthea could be then a different possibility with Maria, Thelma, and Debbie. Okay, and then that's going to give me then, I had 3 combinations here. I'm going to end up with 3 combinations here where A is going to go to M, A is first, then Thelma is second, and then A is first, and Debbie is another 3 combinations. And so on the next one, I can also do the same thing for Thelma and then also Debbie, but I bet you're getting the pattern. So I'm probably going to get 3 different combinations here and another 3 different combinations here. So when we look at this, how many different possible ways, we could go ahead and list them out, and you would, can finish here. Or since the problem asks how many different arrangements of first and second place winners were possible, then you would say that I would have 3 plus 3 plus 3 plus 3, or 12 different combinations. All right, that takes care of this lesson.